This was an exercise related to the astrophysics, and I think I discussed the first three questions with you. Yeah, first three we discussed. We'll start with question 4. So when astronomers, they look for when astronomers are look at distant galaxy, they find that the frequency of a light from a galaxy is shifted towards the red end. Like example, we are focusing on any galaxy, and we found this galaxy is giving us a red shift because frequency is shifted towards the red end of a spectrum, means like it is giving us a red shift. What we can conclude from this, what we can say about this galaxy, is it moving towards us or away from us? So because it's giving a red shift, so it means it is moving away from us. And apart from a visible light, state two types of electromagnetic wave that contain like most energy emitted from the star. So what, for example, when we are observing our sun, what kind of radiation our sun is emitting out? It is emitting out different types of radiation, but what kind of radiations are there from our sun? Number one, it is giving us a heat radiation. So there are heat radiations from the sun, and heat radiation from the sun we call IR, infrared. And there's also another type of radiation which is UV, ultraviolet radiation. Visible is there, that's how we are able to see our sun, but it is also giving an infrared and a visible. And it is happening for all the stars, like they are emitting out. That's how we use a radio telescope to identify the temperature of the star, to identify the distance of star from us. And using all this, we can find the size of the star. So apart from visible, what else the radiations are emitted from stars? It is UV and IR. You can write UV and IR, or you can write the complete ultraviolet and infrared. Ultraviolet means having a higher frequency than the visible, we cannot see, and infrared means that having a lower frequency than the infrared. Then describe what is meant by the red end of a spectrum. So what does it mean, red end of a spectrum? It means like it will have a longer wavelength, or it will have a shorter frequency, because when we compare the frequency and the wavelength for red, like we have the spectrum is there, we have violet, we have indigo, blue, green, yellow, orange, and red. So what are the characteristics of a red? The waves of the red, they are longer wavelength. Wavelength is denoted by this Greek alphabet lambda, and they have a short frequency. And what is the meaning of a violet here? It means that it will have a short wavelength, length of a wave will be short, and the frequency, the number of the waves will be high. So what is meant by, they are only asking what is meant by a red end of a spectrum. Red end of a spectrum means like part of a spectrum which is having longer wavelength and shorter frequency. If you write here that the galaxy is moving away from us, this shows the galaxy is moving away from us. That is, if the question was what you conclude that it is giving a like the wavelength is shifted towards the red end of a spectrum, or frequency is shifted towards red end of a spectrum, what you conclude from that, then you will mention that this galaxy is moving away from us. But if it is if the simple question is like what is the meaning of a red end of a spectrum? So red end of a spectrum means that the wavelength of a wave which are emitted out are longer, and frequency shorter. If you write here 300 nanometer, no, actually it's not correct. If you write the range, when you check the spectrum about the wavelengths, we have violet, indigo, blue, green, yellow, orange, and red. About their wavelength, red is 700 nanometer, where violet is 400 nanometer. This is a wavelength range. So red end of a spectrum means like it is giving most of the wavelength in a longer region. So if you write anything related to that the galaxy is moving away from us, that is not correct according to the question. Only you have to mention what is meant by a red end of a spectrum. It means that the wavelength is increasing, or it is on a longer wavelength and a shorter frequency. Then the speed of a recession of a galaxy is the speed at which the galaxy is moving away from the Earth. Astronomers use redshift to measure the speed of recession. Astronomers can also measure the distance of a galaxy from Earth. Such large distances can be measured in light year. Light year is the unit of distance, how much distance traveled by light in 1 year. Astronomers can estimate the time of the galaxy has been moving away from the Earth by using the equation d divided by speed of recession. Table 4.1 shows their estimated, like 4 different galaxies are there, which are different. Their distance in light year, 4.9 exponent 7 light year, 1 exponent 8, 3.2, 3.9. And these are their recession speed, the speed at these they're moving. And it is found like it is giving the time as 13, 13, 14, and 13. What is meant by the galaxy? So what is the definition of a galaxy? So galaxy is actually like collection of billions of stars. So one mark is, why it's of 2 mark? 1 mark is for mentioning collection. 1 mark is for mentioning billions of stars. So collection of solar system, star, gases, dust. Yeah, that's also fine. But the simple definition for a galaxy is it is a collection of billions of stars. That's it. So how you will score 2 mark? 1 mark you will score for collection. 1 mark you will score for billion of stars. Then show that 1 light year is equals to 9.5 exponent 15. How we can show that 1 light year is this? So we have the formula speed is equals to distance divided by time. Light year is a unit of distance. So distance will be speed multiplied by time. That is equals to the distance. Speed at which the light travel, what is the speed of a light? That is fixed value 300 million meters or 3 exponent 8. So speed of a light is 3 into 10 power 8. Time for the galaxy, because the time is 1 year. So 1 year, how much time is there in 1 year? Like there are 365 days are there. We multiply by 24 to convert into hours. Because the speed was in meter per second, so time should be in second. Then we multiply by 60 to convert into minutes. We multiply by 60 to convert into seconds. So when we multiply all of them, we'll get about 9.5 exponent 15, which is equals to 1 light year. Because 1 light year is a distance traveled by light in 1 year. And 1 year, you just get multiply to get number of the second in 1 year and multiplied by speed of a light to know the total distance. Then describe a relation between speed of recession of a galaxy and its distance from Earth. Speed and distance, how they are related to each other. You can see as the distance is increasing, like this value is increasing, as the distance from Earth is increasing, what happened to the speed of the galaxy? That is also increasing. The distance of a galaxy increases as, speed of a galaxy increase as the distance increase. And explain how the value of a t provide an evidence of a Big Bang theory of origin of the universe. Like how this value of a time for billion years, like 13, 13, 14, and 13. Yes, you can mention the distance and the speed are directly proportional. You can also mention that. So when we work out the time for age of the universe, we are getting a same answer from all galaxies. Like even a galaxy which is close to us, moving at different speed, a galaxy which is distant galaxy far from us, moving at a different speed. But when we work out the time for the different galaxies, it's giving us the same time interval. So that shows the age of a universe, because like some galaxies which are moving, which are closer to us, are moving slower. Some galaxies which are far from us, say this is the Earth and this is galaxy A. So when we galaxy A is closer to us, it is moving slower. And using its speed and a distance, when we work out the time, we found that it is 13 billion years. And there's another galaxy which is far from the Earth, and that is moving faster. And when we calculate like how much time it took to move away from the Earth, both galaxies are moving away, but one is moving slower, one is moving faster. But when we calculate the time taken by the faster galaxy to move away from Earth and time taken by a slower galaxy to move away from Earth, we are getting the same time. We are getting like 13.9 years or 13.9 billion years. So what it shows the age of the universe. So it shows that it all started with an explosion and things scattered, spread away from each other. And because they are giving the same time interval, so that time interval is actually the age of universe. So how you write the answer for this, how you score 2 marks. So you will mention here, like these all time intervals are same, which shows that these all galaxies were initially together, but when it exploded, like everything was 1 point in the beginning. Like this was, say, Earth, this was galaxy A, this is galaxy B. They have different speed, they have different distance from the Earth, but like this was taking 13 billion years. This also took 13 billion years. So what does it mean? Before 13 billion years, it will be like all will be 1 point. That is an evidence of a Big Bang. Big Bang theory state that it all started with an explosion. So how you will score the marks here? You will mention all shows the same time interval. So we can say it all start with same point or a single point. Which provide an evidence to a Big Bang theory. Is it clear, this one? Anyone having a doubt or a question?
No, sir.
Okay. Then question 5, the sun produce energy from nuclei of a hydrogen. Hydrogen nuclei are positively charged. Describe the process that produce this energy. How stars are producing energy? The stars are producing energy by a nuclear fusion. And what actually happened, like lighter nuclei. So describe the process that produces energy. What happened here in this one? So what actually happened, the lighter nuclei, which is a hydrogen nuclei, you have to use the term lighter, like standard definition, it should be lighter nuclei. So you can mention lighter nuclei join together to form a heavy nucleus and release energy. Because these all are exothermic reactions, they all release energy. Then the next part is why this process need a high temperature to occur. Like why initially we need a very high temperature to do this, because what actually happened, we have to fuse the nuclei together, because like charges repel each other. Like example, we have hydrogen nuclei. Hydrogen is one proton and one electron. And there's another hydrogen, one proton and one electron. We want to fuse them together. We want to bring them together. But because these are like charges and like charges are repelling each other, like hydrogen nucleus with hydrogen nucleus will repel each other. We want to mix them together and make one. So if we have to overcome the repulsion, how we can overcome the repulsion? By hitting them, or they hit each other at a high speed. So nuclei repulsion can overcome. So why we need a high temperature for this? So a high temperature is needed to overcome the repulsion between two nuclei, because they are identical charge. So we want to fuse or mix them together. So to fuse or mix them together, we need a very high temperature. Without a high temperature, a nuclear fusion cannot occur. Is it clear, this part?
Yes, sir.
Yes, sir. Great.
So temperature affects the kinetic energy or the speed. The temperature is required to overcome the kinetic energy or the speed, to overcome the repulsion by moving them at a very high speed. Then some stars initially much more massive than the sun describe the life cycle after it has passed through a stage of being a protostar. Like you have to, it's a 4-mark question, so you have to explain the life cycle of a star, which is a massive star. So for a massive star, first what will happen? It will, from a protostar, it will turn into a main sequence star. And when it is a main sequence star, like it has passes through a stage of being protostar. So we don't have to explain what is protostar. We start, it will turn into a main sequence. And when it is a main sequence, what will happen? It will undergo hydrogen fusion. And as a result of a hydrogen fusion, the radiation pressure will be equals to the gravitational force, and the size of the star won't change that point. Then after main sequence, what happened to the star? It will turn into a red giant. When hydrogen fusion eases, the star will collapse, like reduce in size. And as a result, what will happen? It's a massive star, so hydrogen fusion stop. The star reduce in size. This will increase the temperature. And as a result, when the temperature increases, the helium fusion starts. And as a result, the star will be a supergiant, red supergiant. Then when the helium fusion stop, the heavy element fusion start, and there will be a supernova. And as a result of a supernova, that explosion, and this will turn into what? It will turn into either a neutron star or a black hole. That is the star cycle for a massive star, the star which is having a greater mass than the sun. Then although the early universe contained only light elements such as hydrogen, and it is now contain number of heavy elements. State in which part of a life cycle of a star these very heavy elements are formed. So which part the heavy elements are formed? Yeah, that's right. That is in supernova it is forming, because like for when it is a red giant, it is helium is producing carbon, nitrogen, other element. But in supernova, it's like when the heavy elements further fuse, so they produce more heavy elements. So which cycle it will produce? It will produce in a supernova. Then question 6, state the name of a force that keep the Earth orbit around the sun. So all these astronomical objects are moving due to gravitational. So there's a gravitational force. State how many days it takes for Earth to complete the orbit, one orbit of the sun. So that's 365 days, 365. Then explain why sun appear to move across the sky each day. Why it feel that the sun is moving over the sky. Yeah, that's a good answer, because Earth spin its own axis in 24 hours. That is causing that is why we feel that the sun is moving on the sky. So because the Earth spin its axis in 24 hours. One mark is for mentioning this rotation. One mark is for mentioning the duration 24 hours. Question 7. Complete the sentence about the objects in our solar system. Planet, minor planet, and dash orbit the sun. So planets are there, minor planets are there. We can mention comets, asteroids also we can mention. The object that orbit the planet are called. So we call them as the moon, because moon orbit the planet and planets orbit the star. Compare the structure and the size of 4 inner planets with those 4 outer. 4 inner planets. So 4 inner planets are basically rocky planets, and 4 outer planets are basically gaseous giants. And the inner planets are smaller in size, where gaseous giants are bigger or larger in size. So comparison,
Sir,
yeah.
sir, in question 7A, where you wrote moon, I wrote moon and natural satellites.
Yeah,
So
yeah, it's
is
okay,
it
fine.
correct?
Yeah, correct. So inner planets, their structure and the size, so how they're structured, they mainly consist of rocks, and the size, they're small. And outer planets, they are gaseous, and they are larger in size. In question 8, state the name of 2 main elements found in the sun. Which 2 elements are there in sun? That's good, hydrogen and helium. You can use screen annotation to answer as well. You can use your mic, chat, or screen annotation for any question. The sun is one of many billions of stars that make our galaxy. Complete the following sentence about galaxy. Our galaxy is named by, so what we call our galaxy, we call that as a Milky Way galaxy. Sorry, I copy. Yeah. So it's known as a Milky Way galaxy. Then the distance of the Mars from the sun is 2.1 exponent 11. And the speed of a light, calculate the time for a light to travel from sun to reach the Mars. So we have like this is our sun, and it reaches Mercury, Venus, Earth, and Mars. And the distance, if you consider the light is emitted from the surface of the sun, so this This is taking about the distance between them is 2.4 into 10 to the power 11 meter. And the speed of a light is how much? That is 300 million meter or 3 exponent 8. So we have the formula speed is distance over time. So if we need the time, so time is distance divided by speed. So distance is 2.4 into 10 to the power 11 and the speed is 3 into 10 to the power 8. So we divide, we'll get how much time the light will take to reach the Mars. So Earth is about 8 minutes, Mars is about 800 seconds. So it is about 800 seconds. Yeah. In question 9, figure 1.1 shows a comet around Sun. X, Y, P, and Q are different positions. State how the speed of a comet changes as it moves from X to Y. Because as it is approaching, like moving towards, so kinetic energy increases, so speed of a comet will increase. And explain in terms of energy, like, because what happened when the comet is far, it will have a higher greater gravitational potential energy and smaller kinetic. Because the total energy is conserved, total energy is constant, kinetic plus potential is same. But here the comet is closer, so potential energy is smaller, so kinetic energy must be higher so that the total energy is constant. So first we'll mention the total energy is conserved, or you can say constant, which is kinetic plus potential. Then what actually happened when the comet is moved from at X, it is having a higher potential, so smaller kinetic, but at Y, as it is closer to smaller potential, so higher kinetic, that's why the speed increases. The shape of the orbit of a comet from P to Q is circular with the sun at the center. State and explain the change, if any, the speed and its velocity as a comet moves from P to Q. So from P to Q, the distance is same. Like distance of P to the sun and distance of Q to the sun is same. So if the distance is same, there is no change in kinetic energy, so no change in speed. The speed won't change because the distance from P and distance from Q is same. But what happened to velocity? Velocity will change because velocity is a vector quantity. As a direction change, so the velocity will change. So speed, there is no change. And why it does not change? Because there is no change in kinetic energy. And velocity, for velocity it changes. Why it changes? Because velocity is a vector quantity we discussed. If the direction changes, the velocity will also change. Is it clear, this one? Why the speed is not changing and the kinetic energy is changing?
Yes, sir.
Okay, one more question is there that I'll share another link and we will discuss that. Then we'll start our topic about the atomic.